Well, good afternoon. I hope everyone's been enjoying their sessions today. We're wrapping up the end of day one, so I've got a session on JSON, specifically the System.JSON unit that's included with Delphi. It's been in there for a while. It's changed and morphed over time. There's actually two frameworks when it comes to dealing with JSON structures. We're going to be looking at one of them. The other one's a little bit more specialized in its role, but we have plenty to cover, really deep example. We're going to look at one of the reasons why I wanted to have this session is there's several different ways in which the JSON objects network can actually work, and which way should you do it? And the documentation is pretty weak. It's little bits there, but you kind of have to look at the code and then kind of figure out, oh, well, if I call this one, these side effects happen. If I call this other one, a whole different set of side effects happen. So we're going to break this up into three pieces, three parts. The first one's an overview of the JSON Objects Framework. That is the most common of the two frameworks. There's the other one that's for reading and writing and for basically serializing your JSON data in and out of a stream. You build up a writer. If you need that, it can be quite effective and powerful, but for what we're trying to do in the examples, the objects framework is going to be more appropriate for what we're going to be doing, as we will see through the examples. And then I am sure almost all of you, if not all of you, have worked with JSON in some form or fashion, because every web service, most every web service, has that as its payload. So, and that's the two examples I have is we're going to be breaking now is how do we parse JSON using the classes that are in there, and then how do we construct a payload that has JSON in it that we can then send off to another web service. And I'm actually taking input, I'm calling one REST API to get some data, changing it up a little bit, and sending it to another API to get something different out of it. And I wanted to spend a lot of time figuring out a good sample set that's not super big, but has a wide variety of data types in it, especially arrays, because JSON arrays tend to be the biggest culprit that Delphi developers will struggle with in trying to either parse the data outright, especially if it's an array of objects. And so there's some things you have to do to set that up, both in the parsing of the data out and in the construction of it, if that's what you need to provide. My examples have both of those in there. So let's dig in a little bit deeper. So System.JSON, that's the unit that has all of the framework classes, and there's several classes that are involved inside of there. It's designed to support all of the JSON data types. So I'm assuming you all are familiar with that notation. I'm not going into the details, but we know there's strings, there's numbers, Booleans have a special type, they're not quoted. So all of that is built in, and it works great. My little comment there is kind of just a little kind of smart alecky comment to the whole JSON industry. Come up with a date format, let's make it something more native, but we have a convention. And so I'll have some more to talk about dates in JSON a little bit late, toward the end of the session, and some things that I have done in order to make that a lot easier to deal with. So there's two base class. Well, there's the base class is the JSON ancestor. That is the topmost one. It defines the core properties and methods that every other descendant class will take advantage of. Most of them are actually implemented at the TJSON value level. And so a value is a base class that has the standard properties that we would need to get data out. Typically, you can put some data in, but then the specifics get put into all of the descendants. So the common ones is a JSON object. I mean, that's really what we usually get back as a payload. It's going to be made up of potentially arrays, numbers. There's also a JSON pair that you wouldn't construct it by itself. It's usually going to be a pair that's holding two of these other things. So it could be a pair that's holding, a string with an object, or it's a key in an object, or a key in another number, or whatnot. We will see plenty of examples of all of that as we move forward. Do have a couple comments before we get into the code, just some things to keep in mind. Like the VCL, there is an ownership concept, but it's actually it's a little different, it's a little backwards. Instead of saying who the owner is and pointing up into the hierarchy, instances that we create, that TJSON number, the JSON string, the instance of that has a flag that determines whether, it specifies whether that is owned or not. And by default, it's set to true. And owned means that whichever parent class constructed it or caused it to be constructed, it will be one responsible for cleaning it up. So the nice thing is by this default of being true, is that when we go to clean up our work, we don't have to worry about all these intermediate instances that are being created for us or by us connected to a root object. We just need to take care of the root object because everything else is going to be taken care of for us. If you change that for whatever reason, if you felt I have never had the reason to change it, but I'm just pointing it out because if you do, then that cleanup won't take place and you will need to be responsible for doing that. And then the final thing that's kind of related to that is if you are going to be cloning your JSON payload to do something else with it, to send it to two different places, it is a deep copy. It goes through all of the nested objects, creates a duplicate of it, and clones it completely. So that's great. And those cloned objects will now own all of the instances that are under its umbrella. So when it comes to parsing JSON, there are two primary ways to do it. The first, it's been there for a long time, is the TJSON object has a parse JSON value method. It's a class method, so we don't need an instance of it. Typically, you will just see it being being called and typecasted back to whatever we think that object is supposed to be. So if you're expecting back an object, a JSON object coming back, that's what you would start out and cast it with. If you didn't know, you could keep it as a value and then do some checks to see what is it that I got back. If you knew that it was going to be an array, then you could also do that. The key thing is that as a JSON value, we can do more things with it. We can check to see if it's null, if it did come back correctly. Another option is to use on the JSON object an instance method, newer, was introduced in 10.3, called parse. It's interesting because it does similar goals, but they're implemented quite differently when you go look at the code. And one of the things that I've discovered is I personally like to use the first one. One, because that's been there from before, so I've been doing it for a long time now, so I'm like, okay, I know how that works. But the real reason why is that you get better error handling with the JSON value one. You can specify parameters to it that determines how is it going to treat Boolean values. Does it create a TJSON bool, which will hold both values, or does it use the true and the false separate objects? But more importantly is you can control whether or not a parse failure results in an exception that you would trap or not an exception. It would come back as nil. You can also get back information of why did a parse fail from the string or the data payload that you give it. And so to me, that's just a little bit easier to manage and have that control. So when it comes to extracting value, so we've been given a payload. Typically, it comes in as a string. It might be a stream if we're loading it from something, but typically it's just a stream, a character of bytes, got some data. We know that it's going to be pretty much ASCII or UTF-8 for the most part. Easy enough byte characters, we're good. So once we parse it, the parsing engine is basically creating the data structures behind the scenes for us so that it knows, oh, I've got an array that's of these number of objects. There's different name value pairs inside of those objects and so forth. Well, how do we get and traverse our structure? And when it comes down to, once we find the value or the area that we're interested in, what objects and what properties, we're going to typically use the get value of t and the try get value of t. T being the type you expect that property to be. And so this is one of the things where the documentation is a little misleading, because it will say something along the lines of, specify the JSON type that you expect it to be. Well, is that string or is it TJSON string? And it's string. Just the regular Delphi type that you put in there will work just fine, so that it comes back and you get that value in that type. What's also nice with the get version is there is a default value. So if there is a problem with getting it where it's not a valid number or a Boolean, you can provide a default value that it will be successful and give you the default. If you don't know the default or you want to know that it fails, you can use the try version, which has an output variable in the parameter list that will be populated if the parsing of that data type with that name value pair is valid. Now, there's some other ones that you can use. They've actually been around for quite a while. That's at the TJSON object level. So JSON value, remember that's way up there? So everybody has, all of our basic types have the ability to get a value out of it. Makes sense. Now, at the JSON object level, we have a get name and a get index. Index being an integer, name being a string. And it's interesting because you'll read and you see it in the code that the get index has been deprecated. And it tells you to use the pairs property. And pairs is essentially the same thing, except it's a property with an indexer on it. It's the same thing. But they decided, oh, let's do that. Well, what's funny about it is when you go to the get with the name, so it's just the name of the key that you're interested in. So remember, we're in an object, regular JSON object, and we say, hey, give me the value for this named property that's in my set. This is going to give us back that value. And it comes back as a JSON pair. So it gives me both the two. That's why it's just called get, not get value. You get both, which could be very important, especially if that is a nested object. And so we need to kind of do more inspecting as to what we're going to get back. There's a comment that says that's also deprecated. It's not. It's a comment. So you can still use it. I use it because it still makes sense for what one of the things I'm going to show. But I also do show how to use the values with a warning. And so we're going to get all of this when we dig under the covers. So we've gone through, we've parsed our stuff, and typically at some point we are going to want to get a string representation of our JSON that we've either constructed, and we want to make sure that it's well formed and still, before we send it off, or we may want it simply for logging. We've parsed up the stuff, we've now got a JSON object, a structure that's there. Let's dump it out and see if it parsed it correctly. And so there's a few ways in which we can get data. There's three. A string representation. There's to JSON. So again, remember TJSON ancestor is the topmost. So any of those objects, all the classes that we've been talking about, have a to.json. And so it just, whatever it knows about. So obviously the object will know about doing the expansion of each of the properties and then drilling down deeper. What's interesting about to.json is that it will always produce a formally valid JSON string, but no formatting, meaning it is a single line of JSON, which, if you don't care, machines don't care, there's nothing wrong with that. If we want to look at it and try to find out, oh, what was the value of this? Not so good. There is a toString, which is nearly identical to to.json, except it doesn't do any conversion of non-ASCII characters to Unicode characters in that. Just keep that in mind. Maybe, over in the US, we don't care about that because we just all like our English and no special characters, but then you come over to Europe and, it's a little bit different. So, however, what most people will probably want to do is get a formatted JSON string so that it looks nice and it's structured and it's got new lines and indenting to get, show this rich structure that's there. And that is where the format method comes in, which has a default indentation level of 4. You can change that. What's interesting is that in 10.3 and later, you have the format function that is on the TJSON ancestor. So every class has that. Typically, it's the object one you would be using. Well, before that, though, it didn't exist. That was a new feature that was added in. And it wasn't just a new feature. They fixed some issues in the formatting of that, the JSON payload. It handled things much better. Before that, there was a static class off of TJSON, which, again, I haven't talked about any of that. We don't use it. It's there. It had a helper function, basically, to do some formatting. That's gone. Replace it, and I'll show you. You can use a conditional define if you have older code that you need to call that, and newer code that will allow you to call both. So, constructing JSON, it's nearly the same as the parsing side. It's the same objects. Instead of calling gets, though, we're going to call adds and add pairs. So we're going to assemble our set of objects in the same way that we would parse and walk through our structure. Pretty straightforward. I'm getting all the slides out of the way first so we have a context, and then we're going to see into the code how all this comes together. And speaking of, so here we go. Now I get to sit. So as listed here, I'm leveraging two services to get some data and do something with. And so I'm going to, let me just run the app, and then we'll talk about how all of it put together. So I've got the REST client components here, some spinners, but let me just go ahead and run. And MLB stands for Major League Baseball. I'm a huge baseball fan, so that is, I like going after, there's lots of rich data that you can get. There's statistics everywhere. And so I have, this is for hitting stats. I'm actually grabbing for a given season the home run leaders for Major League Baseball. And the top 5 is what I have at the default. So when I go and click retrieve stats, it's making the REST call and pulling back data. So I'm parsing the data. We're going to see that in a moment. I'm parsing the data. I'm printing it to make sure, like, okay, what did I read back? What does this look like? I'm showing on the screen here, what raw data am I interested in? Because I'm going to get a payload of other stuff, and this is what the raw data looks like. there's nested objects, and it's, do I care what time it was created? No, not important for me. But I do want to know the player's name, how many home runs they hit that year, and which league they're in. There's 2 leagues in Major League Baseball, the National and the American. And so I have that tracked. Now that I've parsed my data, and I have my own data structure that I've put together. The JSON that I got back and parsed through is gone. I don't care about it. My native data structure is what I'm working with. Now I'm going to package that up into a new, different payload, because I'm using a chart, quick chart IO, to chart the values I got. So now I'm making a new REST call, which goes out and charts it for me and gives me back an image that I just display on the screen. And here's the various values. Red is the American League, blue is the National League. So I can see, like, oh, what's happened. And it's kind of interesting, because if you go back to, there's a thing called a designated hitter. I know you guys don't know baseball at all. It used to be just in the American League. So when you had that and you retrieve stats, you would often get a lot of red that would show up in there. And I don't know if I went back far enough. Oh, I picked one that was all blue. Oh, did my internet go down? Let's see. There we go. Oh, I got one with blue, which was kind of interesting to where, so you get this mix and the numbers come back. So that is the what this thing does. So what I ended up doing to kind of get all of this to work, I'm going to show, I don't know what tools you guys use to test your REST APIs out. I mean, there's the REST debugger that's in Delphi. It's okay, it's not bad. Postman is another big one. I like Insomnia. It's a little less confusing than Postman. Postman doesn't like to close tabs. So you got the same tab open for each of your client connections. So this is showing the raw calls that I'm making. So I'm sending to this Major League Baseball API what I'm interested in. And I'm interested in regular games. I specify the season. I want home runs, and give me back certain data. So when I execute it, this is what I get back. So this is what I'm going to be parsing. And that's what we saw in the app. And then on this side is where I tried out, this is taking a JSON body, completely different structure. So I need to recreate this. What's kind of interesting about this one is that I'm going to have some n number of players, depending on whatever I've picked. Might be 5, could be 10, could be 20 if I decided to. So we want to make sure we're populating that properly and to generate a right chart. So again, doing that in Postman, great. I wanted to do it in Delphi. So let's take a look at what this code does, and you will have the whole project. So just follow along best you can, but you'll be able to dig in and see how all of it works. So this home run stat, as you can kind of imagine, that represents one data element that I'm interested in. The player, the home run, and what league they are. Those are the 3 pieces, short and sweet, and I just made it a record. And I'm going to have some place to hold n number of these stats, which is called fstats, which happens to be a generic list. Easy peasy. So there's some other things that there's not a whole lot that's in. It's not that complicated. There's some general things I like putting in about activity panels and stuff. I don't have that here. I have the activity panels in my session on managing FMX views. Tomorrow, so you'll see more, same concept, leverage the same kind of architecture. The key thing is we have 2 calls that we're going to make. We're getting hitting stats, and we're generating the chart. So that's the core things that we're doing. We're taking input from the screens or from the payload that we had grabbed for the chart, and then we need to do some stuff with it. For the execute request, as we'll show, is a simple way of executing the request in a background thread, because if you do want to do this in any mobile device, you have to put it into a background thread. You can't run it in the main thread like we can get away with in Windows. Even the Mac doesn't really like it. So this is a common way using the task is a common way to do it. This is an approach that I use with some handlers to separate the code pretty cleanly. So digging in, just a lot of support stuff. I'm not going to go through it, just what URLs we're talking to, the resource format templates that we need to fill out to represent what we're pulling back. That's worked out all the details ahead of time, store that off, we're good to go. Some messages, creating. I will always do this, certainly when I'm testing out. It's a great habit, especially with things like this, where we've got lots of objects, we've got JSON objects that we're creating, we're parsing things, we're clearing out the results. We have our own internal generic list that we're creating, and we're going to clear out each time we run it. Make sure we're not leaking any memory. And then, so when it comes time, when I hit that receive stats button, or retrieve stats, all I'm doing is calling get hitting stats with the season, the number count, and the stat I'm interested, which I'm not letting you change at the moment. But I kind of coded this to where I could change the stats. And for, you guys are baseball fans, home runs is an easy one. There's batting average, there's runs batted in, there's all kinds of stats you could pick out. Keeping it simple. When it comes time to generate the chart, well, all I really need is the season. So, because I'm going to put that in the top of the chart. And what stat still stays the same, it's home runs. So we know what to put at the top saying, oh, this is the 2022 home run leaders for Major League Baseball. Skip over the panel and all that stuff. Clearing the results just clears out the various results. This is the execute request I was talking about. It takes an activity message and a success and failure. Really what this is doing is simply executing the REST service in the native client inside of a task that's running in the background. And on success, it will call the success handler or failure depending on the status code of the REST call. So that is in all of my apps that make REST calls. And so it's pretty simple. Everything is the same, and I know it's going to be called in the back, and it synchronizes back to the main UI once I'm done, ready to process. So what does that mean? Well, for each call that I'm going to invoke the REST call, I'm going to set up what I need in my REST client controls. How many of you have used the REST client controls, the REST request, REST client? Okay, oh, good few. If you haven't, and you're making calls, there's other ways to do it, like you use indie components, or you can use the net HTTP ones to do the same thing. The REST client components are actually really cool. Makes it very easy to manage that. So that's what I do here. So get hitting stats is making that call. So I'm building up, I need a base URL. Well, I want the stats URL. So I set that up. I need what, this is something that I'm doing so that I can't do it if I'm still waiting for results. So if I'm called out to get stats, well, don't call out and do another one until the first one's finished. So this is a way for me to check. I just set the tag to be busy. And what are we doing a get? Set your format for the resource, which is what that's doing. Clear out the body unless you need a body, which we will in the chart side. And then the key thing here is this is going to execute that request, giving it an activity indicator. I'm not showing anything in this one. And then on success, and here's where the real first part of the work comes in. We've gotten the successful call to the stats API. Now we need to parse some data. So get hitting stats success is where we're going to be doing that. And right off the bat, you can see that I've got a JSON value here. I have a whole bunch of JSON objects, a few JSON pairs, and even a JSON array. if you remember, I know it was really quick and you probably didn't get a chance to really see it, but this is the data that we are needing to parse. And we want to get to these nuggets down in here, which are in their own individual objects that's part of the row array, which is a property of the query results object, which is a sub-object of the leader hitting mux, whatever MUX stands for, and then that's in its own outer object. So we've got some work to do to get down to that level. So that's what this code is all setting us to do. Response content is the JSON payload that's come back from the REST call. It's the raw string of data. So first thing we're going to do is try to parse it. So we want to make sure that the parse is successful. And that's one of the things where I'm doing this version and getting a JSON value back only so that I can check to see, did I get back an actual object? If I did, good, let's move on to the next step. Well, what is that next step? Well, what I'm doing here, this is not normal. I'm actually populating the memo with the format. I'm doing the pretty printing here only for information. You wouldn't need to do that unless you really wanted to log it and be formatted. You could do that, but that's what that's doing. But the hitting object, which is that outer one, so that's the first thing I want to go for. So I'm going to see or take my JSON value, now that I know it came in, and I know it's going to be an object. That's what the value is supposed to be. So if it's a successful call and I got a value, it's an object. Could it not be? If they changed the API and sent an empty array, that would fail because it's not a JSON object in that point. So you probably want to wrap everything up in a try except, which is what that try is doing here. There's a try and a try finally down below. So once I have the hitting object, so as a JSON object, I now am going after that first pair, the first nested object that I have. So I'm getting the repeater pair, and that is the leader hitting repeater. So let me find that, get that. Well, did I get that? If I did, great. Let's go down and take the repeater pair and get its JSON value, which if, again, I know the JSON that's coming back, if I'm getting that value and that's there, well, yes, it has to be an object. That's their definition for it. So I'm going to go and typecast that to a JSON object and have my repeater object. So you'll see this pair object, if that's the structure, which is what this is. So then I go down to the next nested object, which is I need this mux pair, the leader hitting MUX. I get that out of the repeater object. This is using the get, gets the name, gives me back the pair. Is the pair valid? Yes, it is, so it's not null. I go down, and now, getting closer, I'm drilling down and finding, oh, well, give me the query results. Give me that pair. Is that pair valid? I've got data, sure. Give me the object that represents that JSON value, and use that to give me the row pair. Well, the row pair is going to have row with a JSON array of objects afterwards. So once I go into here, I know that like, oh, I've got a pair. Give me the JSON value of that row pair and cast it to a JSON array. Great. So now we're almost done. We got the array back, so that typecast was good, and we have data. It's not empty. So we go through and extract out, so because the array gets parsed out, it knows how many elements are in the array. So for each one of those, I end up getting the stat object, because that's the nested object in the array, and now I'm using that get value of string with the defaults, because they're an empty string, which is fine for what I'm doing. So I have my stat object, and I have this home run stat record. I populate the 3 fields for it, and I add it to my stats generic list. And so like, okay, boom, I go through, boom, 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 5 records or 7 records, whatever. I've got my payload. I fall out through this whole list. If I got stats, I now write out the summary down at the bottom. Here's the 5 record values that I pulled back. Great. If I didn't get any data, well, there's something wrong, so I'm going to write out some, error message. And then I got to clean up everything. And if I don't get, I get an error case, I'm going to show some errors, and that is my parsing. So it can be tedious, but this is also kind of the safest, and I'm checking each step of the way to make sure that it is valid, it's what I'm expecting it to. So with that said, and I mentioned at one point, one of the reasons why this library is a little harder to use is because you can go after the parsing problem in a couple different ways. This is one. Remember the deprecated warnings about, use pairs instead, or values? Well, that's what you can. And so I actually have a conditional define up in here. And let me go turn this off. So if I turn on simplified parsing, and we're going to scan down, and what this does is goes to, where's my right here. So simplified parsing, instead of going after the pairs, it instead takes the object and says, hey, I know you're an object, so you're going to have properties in it. Give me the values for the property name I give you. So skip the whole pair concept altogether. So in this simplified version, we don't have any of the pair well, I should take them out because I don't need them anymore. So my repeater object goes after the values of the leader hitting, which is an object. And then the MUX object goes after the name of that. So it skips that, let me get the pair to see if it's there, just go right to the values. And this looks nice. It's shorter. It kind of does the exact same thing. And it works exactly the same way. However, the thing you have to watch for is if you have an incorrect typecast. So if this was actually an array and not an object, or vice versa, if you didn't have the right match, you wouldn't get a nil that you could check because the pair isn't there, and then you could then gracefully get out. That raises an exception. So then you fall out of the whole thing. So, if you were going to do that, you probably want to do more protection to protect that. But it is an option, and depends on what how much detail you're parsing through it. Any questions on the parsing of the objects here in the data? Great. So let me switch over and do the next step, which is the sending the data. And so generating the chart. We're going to go back up to that big method I just skipped over. But what we're going to do is very similar to making the call that we did for the getting the stats. We set up to go after the charts URL. We're going to need a body. So we're going to populate the body of our REST request from a method called getChartBody. And it takes the season. So that's the core thing. Because once we get the success, if our data is right, all we're doing is taking the memory stream of the raw bytes that come back, taking that, putting it into an image, and displaying the image. The cool thing, or the important thing that I'm trying to teach, is how do we create the body of this message from our generic list. So that's what's up here in getChartBody. And what this is doing, as mentioned before, it's using the same objects that we've been dealing with: JSON objects, JSON arrays, different elements, and we're creating a body. So I'm basically going to build up a JSON object structure and use the toString or the format to give me back the data I want to send across. We'd use toString because it's actually smaller, gets rid of all the new lines and carriage returns from it, if you care. So what it's doing is once I create the body, I now need the chart. The format, the structure I had next to me on the screen, but just as a reminder, this is what I'm trying to produce. So I need a chart. It has a nested property. It has a nested object called data that has 2 arrays in it. And one object has 2 nested arrays inside of it. And so I'm trying to produce all of those. So you go through each step. I have a chart. Great. I need to add the chart to the body. So I add that pair and give it the name chart, which is what this does. Now, since it's in my body object, I can now add things to the chart. Well, I need to add the bar chart type. You can change it, all kinds of stuff. Then, if I want to add in the data, I need to create the data object that I'm going to add in and then populate. Well, the data object needs the labels array that it needs, so I need to add that once it's created. Now I can populate the labels by iterating over the stats and go through and build up the list of labels from the player names, and then continue to step through each one of these, doing it in the right order. So as you build up a nested object, you have to create the object, add it into the object it's part of. It's that whole owned concept. So I'm building up the ownership and the structure as I'm walking down. It works. This does everything that we wanted to do. Here's where I'm color coding the stats lead, whether it's blue or red based on the NL. So great. This is walking all of that through. Finally, the options. And once I'm done, I am actually returning it formatted. So I take the body, format it. That gives me a string. And that's what I pass over to the service call. And I get a chart. And it works great. Now, there's very little in there that was really custom. It's a template. I mean, all of that other structure, I know what I want it to be. So an option, which is where this use chart template you could do, is, let me go back up and change that one. A couple defines in here. So the chart template one, so that's the don't use a chart template, so build everything from scratch. Now, here is a chart template, basically the string with replaceable parameters that I want to populate with. So then I just start with a string. Instead of a JSON object, I'm starting with a string, populate with my template, create the things that I need to replace, and then just replace them. So I'm going to create my list of players, and I'm using a string list because it can do the comma separation really nicely, except with these colors. I had to do it by hand, but that's all this is doing, is just give me a string, plug in the things I want, send it out, and it works. And that is another way that you can produce your JSON if you know that most of it's all the same except for a couple different pieces. No harm, no foul. Why go through all the extra work? I was trying to get the version of the JSON writer. And you can use a string builder. And this is the other framework. And for something like this, it works quite well, except our variable number of values that we would have, because we don't know how many we've got. And so we would have to, I haven't gotten to work, so I don't have the code in there. Once I do, I'll put it in there, because it'd be a neat thing to do. So I know there's a lot in there. All the source code will be available. There's comments in various spots. I'll probably add in some more. Any questions before? I guess we have nothing else going on, so we have as many questions as you want, but I know some people probably have to leave and so forth, but thank you very much.